Hey folks, how's it going? This is Mr. Murray coming to you with a little recap video on the Bearings 2 worksheet. In this video, I'm going to talk to you about the breakdown of the Bearings worksheet, and I'm going to focus on mostly problems 1 and 2 on the worksheet so that you have a sense of if you're doing things right so far. All right, and so what we're doing is we're focusing on bearing and distance. Okay, we're taking it a step further. So previously we've talked about bearings, and so we know that we have a letter, an angle, and a letter. And so in this case we would read this as 35 degrees east of south. So I start south, okay, and then I turn 35 degrees to the east. Okay, so what that means is that this is a 35 degree angle. Okay, whereas here, this would mean you'd look north, and then you would turn 80 degrees to the west. Okay, so it's 80 degrees west of north. We also talked about how if you see a measurement like, for example, 37, and you don't see any letters, we're supposed to assume that it's north and east. Okay? So hopefully you've seen my pro tip, and we actually talked about it in our last Google Hangout, which if you haven't seen, I recommend you take a look at that. And so basically, when we're solving problems, I guess there's a little typo. When solving these types of problems, our idea is, one, we're going to pick out the important information. We're going to draw a picture using the information. We're going to use the picture to create our triangle. And then we're going to use either SOHCAHTOA, law of sines, or law of cosines to find the needed information. And we may have to use the inverse rules if we need to find an angle. So it depends on what we're looking to find. Okay, so here's my first example. So a ship leaves port at noon and heads due east at 30 knots, which we need to know that's nautical miles per hour. Okay, at 3 p.m., the ship changes course to south 30 degrees east. Find the ship's bearing and distance from the port of departure, or the point of departure, either way. Okay, so the important information, we need to know that we're starting going due east. We need to know the speed is 30 knots. It's important to know at 3 p.m. we have a change of course. And then I'll highlight in a separate color what we need to know, the bearing and distance from the point of departure. Okay, so let's start with our ship here. Right, here's my north line. And so we're going to start by heading due east. And as you might have seen me do in some previous videos, I'm going to use the built-in Smart Notebook line to help me out there. Okay? All right, and then what we know is that, let's say that this is where the ship is at, okay, at 3 p.m. So what needs to happen now is that we'll again set up our little diagram here. So this is, we need to go 30 degrees east of south. So here's south, here's east, and so we're going to go 30 degrees east of south, right? You start to the south, you turn 30 degrees to the east, okay? And so we're going to continue along that bearing. And now we're going to continue along. So this may actually be missing some information. So let's take a look. So we are going to need to know what this actually is. So what I'm going to do is I'm going to add this information here. Maybe we'll add some additional information. Maybe we'll say, for example, at 5 p.m. Okay? So again, this is not something that you might have known how to do. as I just realized that we might have to have that additional information. That's kind of my bad. So let's say we had to have that. How would this change up the problem? So what that means is that, for example, we're going to go due east at 30 knots, and if we travel for 3 hours, because it's 3 p.m., we'll have gone 90 nautical miles. And let's say we go, I don't know, another 2 hours, which is, again, something that I just kind of came up with so that this problem would be solvable. This would be 90 nautical miles. So what I need to know is, okay, and I'm going to use this purple line right here. Let's make it dotted. This is like an unknown right now. What the heck? Let's try it again. All right. All right. So what's going to happen is, now that it's like, let's say 5 p.m. here, I need to know the bearing and the distance, okay? I need to know the bearing and the distance. So, and I need to know it between the port and this point where I add up. So you can see I've got this whole thing that I need to know. I know this little piece is 90 degrees, but I need to figure out essentially what the rest of it is, because we're going to use north as our reference point. Okay, so I need to start by finding the distance. Okay, and remember, I had to add this information of at 5 p.m. so that I could get a full triangle. So what we know is we're told that this is a 30-degree angle. Okay, and now we need to know what this is. Well, we can figure that out, because this has to make a 90-degree angle between like this would, I guess, be the west line and the south line. So that makes this whole angle here 120 degrees, because we've got the 90-degree angle plus the 30-degree angle. All right. So to find the distance, we need to use the law of cosines. So the distance squared equals 90 squared plus 60 squared minus 2 times 90 times 60 times the cosine of the angle opposite the side, which would be 120. Okay, that's how we set up the law of cosines. And so now, as you can see, I'm going to use my calculator. 90 squared plus 60 squared minus 2 times 90 times 60 times the cosine of 120. And we get exactly 17,100. And I think that's owing to the fact that 120 is a special angle. We haven't learned that, but that is true. Okay? And now what I'm going to need to do to find the actual distance is I'm going to take the square root of that, and I'm going to get 130. So I'll report out as 130.8, but for future calculations, I'm going to use 130.767. I'll round it to 3 decimal places. Okay, so that's the distance. And remember, that is in nautical miles. But now I need to find this little chunk of an angle right here. And so that's going to, again, require the law of cosines. I'm going to use the 60 on the left of the equation, because the side that is opposite that angle has a length of 60. So 60 squared equals 90 squared plus, and I'm going to use the full 3 decimal places, 130.767 squared minus 2 times 90 times 130.767 cosine, and then I'll leave that as theta, right? Because we usually call the angle we don't know theta. Okay, and then so as we've seen in the law of cosines packet, when I solve for theta, I just need to get everything off by itself. So first I'll subtract these two, and then I'll divide because these are being multiplied by cosine. Negative 2 times 90 times 130.767. Okay, so let's start by calculating this. 60 squared minus 90 squared minus 130.767 squared. Okay, so I've got negative 21,600.008. I'll just leave all the digits because it's not that big of a deal. Now I calculate the bottom. Remember, you do it one at a time to ensure, because remember, a lot of the time if you don't do this, it's actually not even going to give you an answer when you do the inverse, which we're going to do in a second. Okay, and now I'll write this, negative 23,538.06. So now what I need to do is I need to do the inverse cosine, and maybe I can just copy paste that. And that is equal to theta. So let's go ahead and figure that out. So I'm going to do second cos, okay, 21,600.00829 divided by, and then remember I'll do second this to get the answer, and I get a theta, and we're going to use 3 decimal places again because we're still not at our final answer. 23.413 degrees. Okay, so what that means is that this little theta is 23.413 degrees. So the entire bearing is going to be that plus 90, not plus 30, plus 90, because we have to also add this 90-degree angle. And so that is going to be, so we've got a bearing of 113.4 degrees. And remember, given that we have not given letters, we know that that is north and east. Okay, and then we have a distance of 130.8 nautical miles. Again, remember the big assumption is I had to add the 5 p.m. Okay, so please make sure, because notice that I didn't give you enough information to be able to solve that. So if you were confused about how to solve the problem, maybe try to add the 5 p.m. in there and see if you can do that out. Okay, but the idea is we're using the law of cosines once to find the remaining side. So that's like what I call like the law of cosines of sides. And then we're using the law of cosines of angles to find the little piece that we then add up to find the total bearing. Okay, so please make sure you understood what I did here. And then when you're ready, I'm going to go ahead and move on to the second problem. So in the second problem, what I'm going to do, I'm going to do problem 2. So an airplane flying at 550 miles per hour has a bearing of 58 degrees. After flying for 1.5 hours, how far north and how far east has the plane traveled from its point of departure? So we're going to call this our point of departure. We're going 550 miles per hour. We know we've got a bearing of 58. So what that means is that means north 58 degrees to the east. Okay. So we'll make our north. We'll make our east. And I want to make sure I grab the right thing here. Right. Okay. And we're going to go 58 degrees. That's the bearing that our plane is going to go along. And I just noticed that I've got to maybe Get that down there. Get that up there. Now, we're going to have been flying for 1.5 hours. So let's take 550 miles per hour. Let's multiply by 1.5 hours. And so we know in this time, if I was going to just pull up my line tool again, here's me going along the bearing. Okay, what I know is that I'm going to have traveled, let me get my pen here, 800, do it in red, 825 miles. In other words, this is 825. So I want to know how far north, let me get this, let's get a dotted line here. So I'm going to do this in green and let's make the line dotted. How far north, okay, and let's do the east in blue. And how far east have they traveled since leaving the point of departure? That's what we need to find. Now notice we get lucky here because this is a 90-degree angle. So it is a right triangle. So that means that we are going to use the method of SOHCAHTOA. Here's the problem is that we need to know this angle right here. But I can get that angle there because I know that the whole angle is going to be 90. We can see that because this is the north line and this is the east line. So if we take 90, which we know is the whole thing, and we subtract the 58 degrees from above, that leaves us with a 32-degree angle. Okay? So this, remember, is going to be the north, and this is going to be the east. So we know that the sine of 32 degrees is equal to the north amount over the hypotenuse of 825. Okay, maybe I'll move this around a little bit so I can get a little bit more room there. So what that means is that north equals 825 sine of 32. So let's do that. 825 sine of 32. So that's what that means, and again you can see this is not drawn to scale. That means that we have gone approximately 437.2 miles north. Okay, to find the east, well, we know that the cosine of 32 equals east over 825. So east is equal to 825 times the cosine of 32. And again, this is possible because we've set up a right triangle. Alrighty, and so that means that the east is approximately we're going to actually, if we round it to one place, we're actually going to call that approximately 700 miles. So based on SOHCAHTOA, we know that we've traveled approximately 700 miles east and 437 miles north. And again, we know that because one, we figured out the 32 because these have to be complementary angles because we know this is 90 degrees. And then because this is a 90-degree triangle, right, a right triangle, we know we can use SOHCAHTOA. And remember, SOHCAHTOA is the lowest energy strategy. So if a right triangle is there, you want to use SOHCAHTOA. Okay, so hopefully you found this video to be helpful. I'm going to again really push to you to fix this problem. I sincerely apologize. This problem does need to be fixed. I will go ahead and take a look really quick. You should be able to solve 3 and 4. You should be able to find 3 and 4 based on what we have. So again, I'm going to ask you today to continue to work through this one. If there are any issues with that, I'll let you know. Don't worry about that because I'm not going to obviously hold you accountable if I'm making mistakes. But keep working at it. I appreciate your patience. I'm looking forward to seeing everyone on Wednesday for our hangout. Stay positive and remember, you can do it. All right, thanks for watching. Don't forget to love math, and you have a wonderful day.